So, I'm Dan. I spoke at the last Serverless Days Cardiff. At that time, I worked for M&G as a senior developer. A lot has changed in 3 years. There's some kind of illness that kind of went around. And I've also gone off and co-founded my own company, which is called Zeti. I'm disabled due to single-sided deafness, so I do try and advocate for disability in developer areas particularly. So if anyone wants to talk to me about that afterwards, I'll be more than happy to. And I co-founded Zeti in January 21, so we're two and a bit years. What is Zeti? So this is the clan, not quite all of them, but most of them. And Zeti finances exclusively electric vehicles on a pay-per-mile basis. So rather than fixed monthly payments, it allows fleet operators, so normally we're thinking like taxi fleets or like a delivery fleet, like a DPD or someone like that. Instead of paying fixed monthly payments, they pay per mile that they actually drive the vehicles. Where that's really beneficial is if there's, for example, a lockdown not long after you start your company, and you're a taxi fleet and all of a sudden taxi fares drop through the floor, you can end up paying £0 for your vehicle finance in a month. That was key to get some of London's taxi operators through the lockdown. We can see on our charts, like literally just these flat lines as those kind of lockdowns came in. But it's also useful on a more day-to-day basis. So the more you use a vehicle, the less valuable it becomes, and it kind of ends up forming like a nice balance. So it's very attractive to businesses. Now, we exclusively offer it to ultra-low emission technologies, and that's because we're very focused on climate and sustainability. So we have a live tracker on our website, which is www.zeti.group, and you can have a check there, and the numbers will be different, I promise. But when I checked it around midday today, we'd saved 6,913,058 kilos of carbon through the vehicles that are driving around on our platform. And the way we calculate that is the fact that they've displaced diesel or petrol vehicles. So they've either directly taken them off the road, or because we're offering an innovative form of finance, they've been able to afford to get these electric vehicles rather than the cheaper petrol or diesel alternatives. We also have started doing, now that we've come off our free Microsoft credits, thank you very much, Microsoft, if anyone's in the room, we've started going down and going, right, well, perhaps we can make sure that Zeti itself is very efficient as well. Because in the early days of startup, frankly, you build whatever you can to make sure that you can keep the startup alive. So recently we went on a drive to reduce usage, and we achieved like a 98.5% cut in our database costs and therefore the carbon emissions, which I was pretty amazed at in like a short space of time. And then we also went through our public website, and something that a lot of developers aren't that aware about, but your website or your web app or your application, every time it runs on someone's physical device, it uses electricity on that device. Now, it's only a very small amount, but in aggregate, that can become really significant quantities of energy. So, first of all, sustainability 101, wow, you can see the difference between the dark mode and the light mode. I can see all of your faces now. You can tell it was like a developer started company because I got dark mode everywhere into the branding when we had the chat. So, sustainability 101, a lot of people hear the words, but sometimes it's a bit vague what it means. So just to kind of give you like a little bit of a 101 course in what you need to do and what actually sustainability is. The biggest step first towards any kind of sustainability kind of journey is you've got to measure. So the most common way that individual consumers know about this is the carbon footprint. So people will go in, and say, right, I cycle to work, so I don't use much carbon there, or I drive a diesel 4x4, so I use lots, or I fly lots, for example. But as a business, you can do the same thing. And where we started to come across this was, we're doing this for Zeti, and we're going, right, well, what about the actual technology platform? How do we measure that? And luckily, Microsoft have have a carbon tracker dashboard that you can kind of put in, and you can get rough estimates. It's not perfect, but it's pretty good as a place to start. Then, once you've actually found out where the bad areas are, and sometimes they're not as obvious as you'd think, you can start putting in plans to reduce. So the best way to make a business sustainable is not to be really, really bad and then buy lots of good things to make up for it. It's to reduce what you're actually using in the first place. So efficiency is always the best start for any kind of sustainability journey. And that goes over into IT as well, right? So you might say, right, well, we're on this cloud provider and they say they're 100% renewable energy, so we don't need to care. We're renewable, it's fine. The fact is the whole grid isn't powered by renewable energy yet, so the electrons that you're using on your wasteful application could have been used instead of coal. So it doesn't quite work. The best way to do it is to actually reduce the amount of energy you're using in the first place. Not that it's not good also to have renewable energy to power your things. And then the other thing to look at is scopes. So a lot of companies, you kind of go, well, we just got an office and like a few people, so we can't emit that much carbon, right? Well, unfortunately, or fortunately, the Sustainability Brigade have thought of that, and there's several different scopes. I'm not going to go into the nth detail of what those mean, but you can divide it into things your company does, things your employees do to get to work, and things that your suppliers do. And basically, it's a way of making sure that you don't end up with like coal mining coming out as squeaky clean, because they don't burn the coal, right? They just sell it. It's up to someone else what they do with it, right? So it's a way of making sure that none of that gets lost. And then the other thing is, we're mostly going to talk about carbon today, and you'll see why on the next slide. But actually, sustainability is like quite a wide field. There's 17 different UN sustainability goals. They're all important. Obviously, the key one that's getting a lot of attention at the moment is carbon. But there's things like air pollution, equality, damage to habitat and wildlife, and they're all important. And your particular context will, you will affect them in different ways. Like each business impacts them in different ways, whether they intend to or not. So, how does tech itself, trying to use a pure tech example rather than getting into individual industries. So how does tech itself impact sustainability? So the first most obvious one is that generally we have a data center, whether it's a cloud provider data center or one that we run ourselves, and we have to plug it in, and then that electricity has to come from somewhere. So that's the most obvious kind of way, and the vast majority of electricity around the world is still produced using fossil fuels. So the reality is, the more electricity you use, the more damage you'll do. Then you also have data center cooling. So data centers, and this applies to cloud providers as well, they're just generally more efficient at it than private companies, though not always. They need to be cooled. So sometimes that's a lot of electricity use, but one thing to also think about is that they use a lot of water. They get through biblical amounts of water to cool their data centers, and particularly in hot countries. So as a top tip, as like a rough guiding kind of thing, if you're choosing the regions where to put your resources, somewhere in the Nordics, somewhere typically cold, means that they won't need to switch into water cooling mode and use as much water. The reason why using water is bad is because it needs to be quite high quality water to flow through all of the pipes properly, and then it's polluted and undrinkable afterwards. So that's, the more you use, the worse that is. It can also raise the temperature substantially, and that can kind of mess with local wildlife and stuff like that. Then we've also got user electricity. So I mentioned this a little bit earlier. Inefficient apps on people's phones use up a lot of energy. If your app is very popular, that can turn into substantial amounts. Things like the BBC News kind of application, if they just reduce the usage, the energy usage of that by a few %, the amount of users of that app, that has a massive impact overall on the carbon emissions on that side. Zeti isn't quite at that scale yet, so I'm not sure that's something that we need to worry about too much. So, how do app developer decisions affect sustainability? Because the key thing about this is like, what can I do? And we'll finish as well with kind of a roundup. But one of the things to look at first is where you're hosting it. So I mentioned physical locations, try and choose somewhere cold. That can be backed up, by the way, with all the cloud providers publish like breakdowns of the carbon emissions and water usage of their various regions. So like Microsoft does it, Amazon does it, Google do it. So you can have a look. And the difference is honestly stark, like far more than I ever imagined when I started looking at it. I knew they'd be different, but it's, you're talking like factors of 10, factors of 100 between different sites. Event-driven or polling. So we've talked a lot about event-driven architectures. They're great. I'm not going to pretend that Zeti has event-driven architecture all the way through. It doesn't. It has some polling in sections of it. Polling is hugely wasteful because most of the calls do nothing. And anywhere where you can reduce polling and go to event-driven, and when I say reduce, it doesn't have to be to nothing. What you could do is say, right, I'm going to check every day for a new thing, but if I receive a message, I'll process that and do that. So like there's the ways that you can keep like a latest version through polling whilst minimizing the amount of work that you're doing. And then how is it architected? So generally, how your application is architected has a massive impact on its energy use. It's a very woolly term. We're going to get more into specifics. But there are things like, if you're running a lot of GPU compute, that's very energy hungry. Do you really need to use GPU compute? There's lots of different decisions that you can make. The key thing is around, and it's down at the bottom, is are you being as lazy as you possibly can be? That's what I always think is the best way to think about how to make an application sustainable, is are you doing the absolute minimum to get the job done, or are you wasting energy doing other stuff? So the other thing is, it's easy as developers, and obviously I've now kind of had a bit of a role mix because I look at business stuff as well now. But it's easy as developers to think that, oh, we just do technology, I make the technology do what the business says. But actually, I would say that your power is more than that. You're delivering business decisions through your technology. And there's things that you can do through that which, small features and tweaks and things like that, which can actually massively impact the carbon output of both your own application and your users. So there's things like, you'll see it on some travel apps now, they'll display the carbon cost of different options. That's a tiny, tiny little change really, and it's a business-driven decision to do that, but the implementation is entirely technical, and it's relatively straightforward most of the time. You can do other things. These are kind of linked, 1 and 2, generally encouraging sustainable decisions. So it's really hard to say specifically what that could be, but it might be like maybe if you're running, I don't know, like an infrastructure company, get them to run their workloads at night. Maybe nudge them, send them an email saying, why don't you run your loads at night? It will be better for the environment because we'll have more spare renewable energy at that time. Then Zeti's gone all in on number 3 in that we don't service clients that aren't sustainable. But there's things that you can do in terms of saying, right, well, actually, if your cars is the easy thing for me, because I'm in that mindset. But if, we've got this app for a car, maybe it reminds you about services and stuff like that. If it's an electric car, I can give you more features. You can get access to extra things. Now, for a car, that might not drive a buying decision, but for other things, there's potential that you could actually nudge your users towards more sustainable outcomes. And then finally, looking at reporting. A lot of this, the step 1 was measure, and a lot of people, where do you even start? You don't even know where to start measuring. That's both in individual lives and in business lives. It's very difficult to actually know how to report. So what you could do is in your application just say, this is the carbon cost of what you've done, and that can be whatever it needs to be. And that might obviously lead to some probing questions from your customers when they realize that it's a lot higher than they thought. But actually that can be a really strong relationship builder as long as you manage it right. So, lots of sustainability stuff to start off with. We're going to get on to some serverless stuff or like more case study specific stuff. So what is Zeti Hub? So Zeti as a company finds lenders who want to invest in green projects. So they might be used to doing wind turbines or solar panels, for example. And we say, look, instead you can invest in electric vehicles. You can lend money to these providers. And what Zeti Hub basically does is manage that entire experience. So they lend money out to a fleet provider. They go out and buy 100 Teslas, for example, and we bill them on their mileage. We issue payment requests. So, like, I think we issued a direct debit payment for $500,000 the other day to give you an idea of kind of the scale of some of these payments that we're taking. And this is all kind of managed through Zeti Manage. So Zeti itself uses this internal tool. This is 100% serverless, end-to-end, the whole thing, manage, invest, and operate. And we can also adapt that to different metrics, so you can do like kilowatt hours and bits and pieces like that. And then we have invest and operate. These are like user-facing portals. So if you're an investor who's lent a bunch of money to buy some vehicles, you can go in and see, right, where are the vehicles for a start? We've had a few instances where drivers have decided to take them to Lisbon on holiday when the finance says you can't leave the UK. That's been fun. So they can monitor that kind of stuff, but they can also monitor like their ESG savings and all that kind of stuff. So, how does it actually work? It's 100% serverless. We have, the text hasn't come through quite as well, but that is like a typical user-facing portal for us. It's all hosted on Microsoft Azure, so I might use some AWS equivalent language whilst I'm going through, as that seems to be the typical way. So, up at the top there, you've got 2 people. Then you've got a blue box. That is what's called an Azure Static Web App. I think I heard mention that there was a workshop on Azure Static Web Apps. So who went to one of those workshops? No one. Maybe I just can't see. But we also, that is basically an equivalent to AWS Amplify. So they're kind of similar things. Then we have an Azure function, which is very similar to Lambda, but it comes with its own hosted API, HTTP kind of handler, so you don't need to have like a, I can't remember the name of the service, but the service that typically sits in the middle. And then we've got Cosmos, which is an equivalent to DynamoDB. So pretty standard like 3-tier application, really. We also use Azure Redis cache. So I've immediately been caught out in a slight fib in that probably you couldn't consider Redis cache 100% serverless, as you do need to choose what size it is and things like that. But it's close enough. And I actually have another talk on serverlessness, which sadly I don't have time for today. Then, in terms of the other architecture, and again, the wording's kind of not come through as much here, but we have timer-driven flows. So every month, we need to go off and calculate some bills. And we use something called Azure Durable Functions. So Azure Durable Functions is a bit like AWS step functions, in a way. I actually really like them. I've used both, and I do genuinely prefer the durable functions one. But it basically allows you to do these long-running, workflows. And we go off and we, pull every single odometer from all of these vehicles out in the road. We've got these 4G light dongles that plug into all the vehicles. We go on, right? What's the mileage of this one? What's the mileage of this one? Pull it all through, calculate the bill, send it to the customer, submit the payment to Stripe. Jobs are good. But we also have a flow where we need to supply the investor or the operator with up-to-date data. So we need to do that like mapping data and stuff like that. And the way that we previously did a bunch of that was we just had timers running every couple of minutes, just making sure they have the latest position. And as I said before, it's kind of wasteful. So how do we cut 98.5% of our database emissions? We did not do this, although I did think it was quite funny. So XKCD, we did not delete the entire database table to just cut down our usage. Instead, we were slightly more responsible than that. So one of the things to remember with serverless stuff, one of its great powers, but also I think one of its kind of problems from like a sustainability point of view, is that it just scales infinitely and doesn't need any management. Now, that's great, and it does actually have its own benefits on sustainability that I'll go into later. But our Cosmos DB, we basically haven't looked at it since we started the company. I was just like, just keep shoving stuff in there, and so long as the startup's still going, it's not my priority right now. And that was helped by the fact that obviously we had startup Azure credits, and most AWS startups will have the same thing. But all of a sudden, we had to start paying for our Azure cost, and my finance director was like, "This is getting kind of expensive. Like, what's going on?" And this is where actually, when you're looking at sustainability, your best friend is finance, because generally, on serverless architectures particularly, you pay for what you use. So if you use less, you pay less. So they're gonna love it, any kind of sustainability push. And this was the case here. So I had a look in, used App Insights, which is like the built-in kind of logging tools. They're pretty good on Azure. You don't really need like third-party ones. And the classic thing, there was some queries which are going off to the database repeatedly and going, I want this one, no, I want this one. No, and it was changing that to a bulk query for more efficiency. And then we also changed some of the flows to be semi-event driven rather than timer driven. So what we had, it's kind of hard to see here, but we've got an addition up here, which is we were now told when a user logged in. And when a user logged in, we could up the refresh rate of the application. And then when a user logged out, we could drop it again, simply by the absence of an event. So what that allowed us to do is massively drop our polling rate, and that in itself solved a massive portion of the problem, coupled with some just query inefficiencies. And then one of the big benefits here is in a conventional system where you got to the point where you've right-sized for whatever you're using, we wouldn't be able to immediately realize all of the benefits from that saving. We'd have to wait until we were very confident that those kind of usage patterns wouldn't come back. Because you wouldn't be able to just go, right, I've pushed the change into prod, and CPU usage has gone down from 40% to 10%. So, right, let's resize the instance immediately. No infra team in their right mind would ever allow you to do that, because they'll be like, what happens next Tuesday when someone else messes with that change? But because the system's serverless, we just started benefiting immediately. I mean, our bill instantly went down, I think, by 60%. And just, that's the real power and kind of good side of serverless and this kind of sustainability angle and kind of cost-driven angle. Then, previously, our system was kind of running all the time. So one of the main advantages of serverless architectures is they could go down to nothing. But because we were having to poll so regularly, actually, it didn't ever go down to nothing. So you kind of lost one of the core kind of benefits, both cost and sustainability. And our user experience generally improved. So, whilst generally things scale really well in serverless architectures, I think everyone who's put one under some serious load has experienced, there's a little bit of a, okay, you actually want to use lots and lots and lots. And sometimes users can experience that as a bit of jank, or people call it cold start or whatever. So generally, user experience has improved, and all we did was edit a few queries. And we cut our bill by 60%, which is fantastic. In terms of future changes, and I think it's been spoken about in a few talks up until now, so I've been working on just publishing those events directly into the browser via WebSockets, having the thing flow all the way through with Kafka. And there's an Azure Web Pub Sub service, which is suitable for that. And I think it was IoT Pub Sub or something. I can't remember the exact name on AWS. But this is kind of the next stage for us. It's like getting to the point where there is no polling at all. And it's just purely all the way down to the customer is all event-driven. And it'd be great once we get to that. And then our public website emissions. So we managed to cut those by 80%, which is a real, like, kind of brilliant step because you can't control how many people go on your public website. You know, particularly, I don't know anyone who's ever managed a public website, but the hits you get are so random from around the world. The spikes you get are really random as well. You know, all of a sudden you've got like 5,000 users from Mongolia on there. And it does just happen, and you can't really control it. So just being able to passively say, actually, to load on a device, this takes 80% less carbon, is a fantastic, like, low-grade way of improving your carbon emissions as a company. And it's something that you can brag about. There's like little badges that you can get on your website that says this website is hosted on zero-emission infrastructure. This website's, I think it's the green coding standard. Might have got the name slightly wrong on that. So our old website relied heavily on React because all of our internal apps did, so we just tried to use the same thing. The problem is with React is that every time a user logs onto it, it spins up as though it's the first time it's ever spun up and starts issuing commands to the customer's CPU saying, right, we need to work out where to put this, we need to work out where to put this, we need to render this, all of this kind of thing. And there's a really great language for that, and it's called HTML and CSS. It did that a long time ago, and it's very, very efficient, much more efficient than any kind of React stuff is. So, but we still wanted to use React because that was the, that was the language, the library that we understood best. So we switched over to Gatsby and went on a murderous campaign through all of our libraries to cut all the ones that we didn't necessarily need. And we managed to reduce the usage by a large amount. And Gatsby is what we call a static site generator, SSG. So Gatsby isn't the only one. There's a whole bunch of them. Hugo, name a front-end framework, and there's normally some kind of static site generator that goes with it, or there's ones that stand on their own. And they're fantastic for these kind of, well, as we say, static sites, public websites, blogs, that kind of thing. And they really reduce, what they effectively do is they run your React code once in its own build process, and then output the HTML, and then when a visitor comes to the website, it uses that first rather than your React. So that's the innovation, if you like, is that it effectively pre-caches the output. And it's faster, user experience is better, way more usable on mobiles because mobiles are way more affected by dodgy signal. If someone's on 3G on a train or whatever, if it's a much smaller website, it can get to their phone quicker and they can actually use it. They might end up becoming a client, all of that kind of good stuff. So the key question is serverless good for sustainability? And I can see you all again. So it's an interesting question. So we found that free credits plus unlimited scaling, potentially not the most ideal thing for sustainability. We didn't even realize we were using that much because we didn't have to pay the bill. It was only once we had started having to pay the bill that we were like, oh yeah, this is actually quite a lot. But on the flip side of that, there's a strong incentive. You can literally put a dollar amount on what delivering a certain feature will deliver to your bottom line, which is a fantastic incentive to actually get some of these things through. If you can say to your finance director or your product manager or whatever, if I do this, it will cut the monthly cost of this application by £5,000. They're going to be able. That's a number they can understand, right? And you can start to get those kind of things pushed in. It's very difficult outside of serverless architectures, I think, to actually do that because you can say, well, we might be able to downsize the instance, but actually, Dave's putting in this other feature that uses more energy, so we might not be able to do that. Then we also, when it comes to serverless stuff, if it's not running, it's not emitting any carbon, which is great, and that's particularly for hobby projects and things like that, that is a key kind of difference, I think, and kind of key benefit. And then this one at the bottom is kind of quite a loaded one that I was debating doing an entirely separate slide on. But it's generally run much more efficiently than customer-run architecture is. So if you're a company and you're running a Kubernetes instance, for example, that you're hosting yourself, you've got a team of, say, probably 3 people, because they need to have holidays because they're human beings, who have to maintain that. That all goes into your scope carbon emissions, because they all have to get to work and come from work. And those 3 people at a cloud provider would manage 15,000 times, the amount of infrastructure, right? They'd be overlooking Kubernetes, like hundreds and hundreds and hundreds of Kubernetes pods, rather than just the ones for your company. So efficiency-wise, the kind of serverless style is far more efficient. The other one, which is not going to be popular with developers, but we had some trouble plugging in this laptop into the presentation, and thank you to the BBC guys for lending me an adapter that actually worked. It's a MacBook Air M1. That has been my only laptop for 2 years. To put that into context, we built a startup on a MacBook Air M1. The reason why you can do that is because all your stuff's running in the cloud. So you don't really need, 32 gig of memory and like all of this kind of stuff. And that's actually a key, e-waste and using way too much electronics for small jobs is kind of a key part of how technology does impact sustainability. And yeah, don't get me wrong, I want a bigger screen, but I don't really need more power at all. And it's quite an interesting side effect, which, don't get me wrong, I still want a more powerful computer, of course, everyone does. So, what can you do? So, evaluating your cloud provider is a key start. So, the first thing you can do is look at the brand, if you like. So, AWS has come on in great strides, but Google and Microsoft are both have, I guess, longer history in terms of being net zero. But you need to look into the regions, as I said before. And then architecting carefully. I think, when you're in a startup, people presume that when you're in a startup, you've got a green field, so you can just do everything perfectly from day one. You often get that kind of vibe from conference talks and things like that. Oh, it's greenfield, you don't need to worry about anything. But actually, I've got to deliver something that works and looks decent in a very, very short space of time. Otherwise, we don't get the funding that we need to run the company. So that can lead to you making decisions which are less efficient, but are done quicker. So it's not like it's just a perfect world in startups. So if you can architect carefully, that saves you, you don't have, the best cure is avoidance, right? So, but once you've done that and you've got something running, you've got to measure and react. So actually put in some monitoring tools, have a look at the actual usage patterns, maybe book in once a month, go through the top 5 queries on your database and be like, are these useful? Is there any way that we can do these better? And the other thing as well is, as you add features, what happened to us was that we had 2 features that were added that none of us ever imagined would have a high usage pattern. And all of a sudden they did, and it was only the monitoring that kind of caught us. So that monitoring can't just be, well, it's fine, we'll leave it for 6 months. Really, you need to keep looking at it, because it's very easy when you're adding features to accidentally massively increase your carbon usage, as we found. And as app developers, I think someone earlier spoke about Lambda that had been running for 7 years. So when these carbon emissions are not it's common to think that your impact is really tiny. Actually, if you've got systems running for 30 years, you've got systems running, cloud systems already running for 7 years, small decisions you make now can actually have massive lifetime impacts on the carbon emissions of that piece of software. And it's kind of part of all of our collective responsibilities to say, well, we're actually going to try and do something about it. We can't be perfect, no one can be, but if you actually try and put some effort into it, you can make massive differences with only, short kind of periods of work. And that's me. If you've got any questions, feel free to add me on LinkedIn through the QR code, or come up to me afterwards. Thanks very much.